Alright. Okay, nanti masuk balik. Ya. Yeah? Okay, so nanti dia orang masuk balik. Ya. Yeah? Alright, so I will recontinue my presentation. Ya. Yeah? So unlike the heat conductions, which is the equation is okay, pada dia, and then ideal. Mana ideal? Okay, pada dia tak cukup bilik. Oh, kenapa dia ada limitations ke? Dia masuk seorang kena keluar. Nanti you have to log in dengan apa nama tu UiTM punya UiTM punya email baru dia stable sikit. Okay. Boleh? Alright. So saya continue. Ada seorang Amin terkeluar tadi. Okay. Alright. So saya continue dengan presentation saya. Right. So for the heat conduction, Q is equal to apa dia? K A dt kan, ataupun delta T. Okay. So but for the convections equal to HA delta T. Alright. So this you are going to develop berdasarkan kepada the condition of the fluid, which is depends on the Nusselt number. So the Nusselt number, which is developed by William Nusselt, so which is I'm not introduced him before. So it is developed by William Nusselt. So what did the Nusselt number indicate for? It is a non-dimensionalized value, which is the ratio between the heat convection HL and the thermal conductivity. Okay, so based daripada sini, what you're going to have is actually the conditions for the Nusselt number. So in this chapter, you're going to see the development of the correlation of this Nusselt number, okay, which is respect to the convection for external, forced convection, and natural convections. Okay, so if you go through this slide, this is what the essence of this chapter, the development of the Nusselt number toward the natural and forced convections. Okay, so the Nusselt number is the ratio between the heat transfer for the convection and the heat transfer for the conductions. Okay, daripada sini that develop the Nusselt number. Okay, and this is the dynamic viscosity because we're going to involve with the fluid. Okay, so thus the fluid will have this criteria. The viscosity, ada yang masuk tadi tu mungkin Amin ya. Cak. Okay, no Azmi. Okay, no Azmi. Alright. Alright, so I'll go back to this presentation. Okay. Oops, start daripada awal balik. Okay, this one. So dynamic viscosity and kinematic viscosity. Okay, so before we go to the flat plate, this is the analysis. I mean the principle of the. We have to look on the principle of the boundary layer, velocity boundary layer, because similarly with the apa nama tu, the thermal boundary layer, similar with the velocity boundary layer, we also going to develop the thermal boundary layer for the heat transfer. Okay, so this is the velocity boundary layer. As you can see, the U, and then which is the thickness of the boundary layer when the velocity is equal to the local velocity is equal to 99% of the free stream velocity. Okay. So this is the development of the boundary layer region, and this is how that we distinguish between the region that you have in the boundary layer, where you have the laminar flow region, transition, and turbulent region. Okay, so saya skip laju kat sini. Okay, then if we apply this toward the thermal boundary layer, okay, so where you have a free stream temperature and then the surface temperature. So yang ada kat sini, this is the surface temperature. Okay. Oops. So this is the surface temperature. We call it as a TS. Okay, and this is a free stream temperature. Then you're going to have a development of the temperature profile. So this temperature profile, where T stream temperature is T infinity. So the thickness of the boundary layer is when is equal to these equations. Okay, ataupun the temperature difference when it is approaching about 99% of the free stream temperature. Okay, so another important parameters that you have to look in the convection is the Prandtl number. So this is the definition of the Prandtl number. You can refer to my YouTube presentation. Okay, and then as well the Reynolds number. The Reynolds number is the ratio of the initial forces to the viscous forces. Okay, so a larger the Reynolds number, a smaller Reynolds number, what will be the effect? Okay, force convection on the laminar and turbulent flow on the surface. Okay, so bahagian sini saya akan skip, and then finally you have to look on the development. Okay, so this is the thickness for the velocity boundary layer, you kena ingat. Okay, and then this is the Prandtl number. Ada yang nak masuk tu seorang tu maksudnya. Ya. Yes. Shafiq. Okay, welcome Shafiq. All right. So this is the thickness boundary layer. Okay, sorry. Okay, finally you have the correlation for the heat convection coefficients. Okay, and then finally this is the correlation between the Nusselt number with the Prandtl number and the Reynolds number. Okay, so this is the correlation where this is the local Nusselt number. So if you can see that before you ada the flat plate tadi kan, this is the development from the flat plate, and this is the development of the velocity boundary layer. Okay, so and this is the location of the local location for the respective of the Reynolds number that you're going to develop. Okay, because the Reynolds number is equal to rho VL ataupun rho VX bahagi dengan U. Okay, Prandtl number you can get it from the property table. So X is reflecting on this value. Okay, then you have the local frictions, which is Fx, that also can be determined, okay, which is CFX. Okay, so this is the local friction, okay, which is 0.664, Reynolds number 1/2. So this is for the laminar flow conditions. Okay, so which is from these frictions you can calculate actually the losses, friction loss, friction ataupun that is called as drag loss. Okay, so dengan kata lain, if we can develop the drag forces, force drag developed on this flat plate, if we can measure the flat force acting on this flat plate, then we can rederive the CD, then we can recorrelate with this equation. Go back again to this value. Okay, maknanya kalau kita ada value untuk drag force, kita boleh measure the drag force, kita boleh correlate balik dengan CF, then we can know what will be the correlation for this one. Okay, the Nusselt number semula. Sebab the Reynolds number dia akan recorrelate balik dengan this one, which is the Nusselt number. So this from the Nusselt number, kita boleh dapatkan semula the value for the yang ini. Okay, so ada that another section from my presentation that we correlate semula antara the friction force to the drag force, dan you can calculate balik semula dengan the heat convection coefficients. Which mean that kalau you do the experiment on the flat plate, you measure the friction on the flat plate, then you can get the value for the Nusselt number for this the heat convection. And if we integrate, okay, this is if we integrate the heat convection throughout the length of the flat plate. Let's say that this is starting daripada x equal to 0 sampailah this is the length which is equal to L. Okay, kalau you masukkan dalam back into this equation, then it can derive the laminar flow for over the entire flat plate, which if we give with these equations. Okay, and the correlation of the thermal boundary layer. Okay, so this is the thermal boundary layer that correlates the velocity boundary layer. Okay, and this is an example. Saya skip this example. You boleh go through selepas ini sendiri. Okay, okay. So let's move to over entire flat plate with condition for the turbulent and with mixed laminar and plus turbulent. So what does it mean by turbulent? Turbulent is the chaotic flow. Okay, because you can imagine that flow dalam keadaan yang energi yang tidak kuat, it will interact between each other. So dia akan dalam keadaan yang very good discipline, so it will have a very good streamline. But when the molecule receive more energy than another molecule, so it start to react more. Okay, so which means that it try to take over one molecule to another molecule. So this will develop a chaotic flow. So this chaotic flow will known as the turbulent flow. Okay, because of one energy want to try to take another energy. So you tengok dua energy molecules try to take another molecule. Okay, they have more energetic than the another molecule. So it will start to swirl and create a chaotic flow. This swirl and chaotic flow is known as the turbulent flow. Okay, so for the turbulent flow all over the flat plate is given by these equations, and for the mixed combination between the laminar and turbulent flow is given by these equations. Okay, for the flat plate, then dalam saya punya PowerPoint yang you can download daripada YouTube, ada apa nama tu, there is a 3 assignment given. So you kena buat in that assignment to ensure that you understand the about the heat convections. Yeah. Okay, so this one you can go through. Okay, so that was for the flat plate. And this one, when you have a flow running on several type of the features, like for example, cylinders and spheres. Okay, and then as well for the cylinder developed by Churchill and Bernstein, this is the equation given. Which is this is the empirical equation. Macam mana dia buat this empirical equation? So also will be discussed in the similarity punya condition. Nanti akan ditengok, but I will skip that part. Yeah. And this is a Whittaker for the empirical correlation for the sphere. Yani for the cylinder, which is it can be Jakobskas and Jacob also conduct another empirical correlation. They conducted the testing experimentation, and then they found out they developed the empirical correlation for the experiment. So this is what they have for the cylinder type cross cylinder circle, and then square for the conduit, and then tilted conduit. Okay. So from here you can see that this is a correlation antara Nusselt number with the Reynolds number and the Prandtl number. Reynolds number and Prandtl number. Reynolds number and the Prandtl number. Okay. And you can follow this apa nama tu di guided tutorial. Oh, dekat 33 minit dah. Okay. Right. So this is a guided tutorial that I given. Okay. So this is the similarity how this development of the correlation that they have done. Okay, similarity, which is the similarity is that the combination of many variables and then it come up with parameters. Okay, so these variables such as the velocity, surface length, wall temperature, freezing temperature, and they come up with only 2 parameters. Okay, kalau you nak summarize this one and become as the mapping, then this is going to be very difficult. For example, you nak kena buat graph untuk graph temperature lawan dengan Reynolds number, something like that. Okay, and then you have another graph temperature lawan dengan pressure. You have another graph, ada yang masuk tu, ini ada signal. Sekejap ya. Saya nak kena accept, nanti dia tak boleh nak masuk. Okay, so welcome Amir Rashid. Alright. So dah ada 24 orang, mungkin another 4 person, kita tak tahu ke mana dia pergi. Alright. Okay, so let's continue dengan this presentation. Alright, so then these parameters daripada pen color apa pula? Color purple. Okay. So then you have the length, velocity, and then it become the Reynolds number and the Prandtl number. Okay, so because this is a summative parameters, yeah, even you can draw the direct coefficient melawan dengan Reynolds number, which is based on the similarities punya concept. Okay, Reynolds number analogy. This is what I have explained before. Okay, you have the frictions, then friction forces, direct force, which is you can develop correlate it with the yang I mentioned before. Okay, direct force with the Nusselt number. Okay, which is yang ni kalau the experimental work that they have done. Yang mana C Reynolds number to the power of n and the Prandtl number to the power of n. So normally dalam the experimentation work, kalau let's say that you have the variable C example, and then you have the value for A. This is the general values, yeah, A, and then X to power of B, and then Y to power of C. Okay, something like that. Okay, so these are the parameters that we are going to look. For example, this is going to be the Reynolds number, and this is going to be the Prandtl number. So this is how they done the experimental work, which they control the parameters, Reynolds number and the Prandtl number, so that they can get the another non-dimensionalized value, which is the NASA number, HL bahagi dengan. Okay. So this is also the parameter. So this is a parameter correlating antara one parameter to another two parameters. Okay. Alright. So NASA number, which is the function of Reynolds number and the Prandtl number. Okay. Alright. So this is they akan develop another one, which is the center number, the analogy. Okay. Which is correlating antara the frictions and the this correlation yang that I have mentioned before. Okay, these correlations. Right, and this is the example untuk the development of the drag force and correlate with the NASA number and the Prandtl, NASA number and the heat convection coefficients. Okay, right. Okay, so as for the internal flow, the prosesnya sama juga, which is only that you have to ensure the development of the heat convection coefficient has to look into the correlation with the Reynolds number and the Prandtl number. We cover for the laminar flow and the turbulence flow. For the laminar flow and turbulent flow, you boleh dapatkan daripada bukunya, the correlation, you can refer to the textbooks ada dalam tu. Okay. Alright, so this is development. Dalam saya punya presentation YouTube tu tak ada, I think tak masuk kan that one. So ada yang nak masuk lagi seorang tu. Sekejap. Siapa ni? Rezwan. Okay, Rezwan. Welcome Rezwan. Ada 26 orang dah masuk. Tinggal lagi 2 orang. So lagi 2 orang tu ideal. Nanti tolong cari 2 orang tu siapa yang tak datang. So that nanti you let me know kenapa dia tak dapat masuk. Ada problem ke apa ke. So anybody yang ada masalah dengan apa nama tu di internet streaming apa, please let me know. Kalau especially yang berada di Shah Alam lah. Yeah. So I continue with slide presentations. Okay, so this is a calculation. Okay, so this is finally for the free or natural force convections. Sorry, natural convections. So which is begin with the apa nama tu? Saya pakai hitam. Sorry, saya pakai color purple. Okay. Thermal expansions, volume expansion coefficient beta, which is correlate with the 1 over rho gradient P over gradient P over gradient T, which is discharge coefficient. I'm sorry, the volume expansion is the inverse of the 1 over T. Okay, which is the inverse of the temperature. Okay, so this is the development of the Grashof number, where as you can see velocity profile where U at the free stream condition is equal to 0. And the temperature from the free stream, sorry, the surface temperature until to the free stream, you see the profile is given by this profile, and the velocity profile is given by these conditions. Okay. All right, and this one is the development of the Grashof number, which is given by the Grashof number. The Grashof number is gravity, volume expansion, temperature difference, characteristic length, and then the dynamic viscosity. Grashof number measure the relative magnitude of the buoyancy force and the opposing viscous force acting on the fluid. And then another person called as the Log Rayleigh has developed the correlation antara the combined the Grashof number and the Prandtl number, and it has become as the Rayleigh number. So this is the Grashof number and this is the Prandtl number, and it become the Rayleigh number. Okay, where the correlation of the Rayleigh number is given by this one. This is for the horizontal cylinder. There are few more correlation yang mana tak masuk dalam ni. There are few more correlation which is you have to look dalam textbook the correlation for the yang ini. Saya lupa nak masukkan. But anyway, nanti I will include this into your note. Okay, ada few more correlations lagi. Not just with the horizontal cylinder, vertical cylinder, and few more correlation for yang sini daripada table you can refer to the table from your textbooks. For all of the correlation between the Nusselt number with the relay number that we have. Okay, so this is guided tutorial. Right. So the presentation I will keep, and then this is going to be saved here. Okay. So yeah, that's all for the presentation. Anybody? So do you have any questions to ask? Ada soalan tak semua? Any questions? Boleh on mic? Fahmi? Ada tak soalan? Do you have any questions? Ada? Alright. I suppose semua dah okey ke? Boleh tak? Atau semua dah tidur?
InsyaAllah okey, sir.
InsyaAllah okey So I give you 3 assignments. So semua ada 3 assignments. So I hope that you will continue with that assignment and then submit on 30 hari bulan. So kelas hari Isnin tak ada. Nanti hari Rabu, then kalau ada tutorial then please let me know nanti. Kalau ada soalan dalam tutorial nanti saya try to compile a few more tutorial to give to you. Just to ensure that you can follow my slide that I have given to you guys. So my concern another 2% ni yang tak datang. So I hope that nanti saya boleh share balik lah dengan di slide presentation yang I dah bagi tu. Okay. Ada soalan lagi tak? Ada any question you want to raise? Macam mana nak buat assignment, nak submit, semua pakai typewriter lah, tapi jangan copy antara satu sama yang lain dan nak bagi cantik sikit. Alright. So guys, ada soalan?